This is an introduction to exercise 5.2 on combining transformations. We're focusing on the idea that not only can we have a singular dilation, reflection, or translation, it's possible for us to have two or more. Okay? Now, when we're combining, the idea is that the order of transformation is very important. Okay? I mentioned this last lesson. It's very important which order we apply them in, because a translation and then a dilation can be very different to a dilation and then a translation. Okay? So, and also obviously whether it occurs on X and Y. We're going to continue using that terminology in the X-axis or along the Y-axis, etc. Please make sure you try your best to understand it. If you need to, you're welcome to write them down in your resource book, but I'm sure you'll get used to it over time. Now, just as a quick heads up before we start, can I get everyone to copy this down into their book for me, or booklet, sorry. That's a general form, don't stress. Basically, it means in general, we go dilation, reflection, translation. In general. And it'll apply later on in the later questions as well. But dilation, reflection, translation, or Dr. T, some of it might be easier for remembering. Let's jump into our example. Beforehand, we're asked to find for example, translation or the dilation, etc. Now we've got multiple steps. In this case, we're finding the image of y equals to root x under a certain amount of transformations. I'm going to focus on the f of x pathway. You're welcome to use the coordinate mapping. You're welcome to do that. And I'm happy to go through that with you later on if you need to, but I'm going to focus on the f of x formatting for this case. So again, I'm going to write f of x equals, and now let's look at our transformations. A dilation of factor 2 from the x-axis, followed by blah, 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 and then blah, blah, blah. So we know it's in that order, okay? A dilation of factor 2 from the x-axis. Now, if it's from the x-axis, are we stretching or dilating vertically or horizontally if it's from the x-axis? Thank you very much. It is vertically. We are dilating this way. In which case, we're going to multiply f of x by 2. I should not be writing it equals there, sorry, it should be an arrow. So f of x goes towards 2 times f of x, makes sense. It's followed by a reflection in the x-axis. A reflection in the x-axis means that the x-axis is acting as our mirror. Therefore, it mapped to negative 2 f of x. If you're not sure how these transformations apply, please go back and make sure you finish off reading that booklet section on page 8. Then it says a translation of 2 units to the right and 3 units down. Of course, writing 2 units to the right is not preferable if you're writing the answer. But in this case, we're thinking, okay, well, it's going to map to negative 2 f of x. That's 2 to the right. It's affecting the x, so we do opposite. If you're wondering why we do the opposite, we're compensating, right? So for example, in order to get x to be the same, in x, in this case, would be minus 2, your value of x would have to be 2 larger, okay? Don't stress too much about understanding that, but just know that we're compensating for x values, which is why we do the opposite. Same thing for dilation. And of course, a minus 3, because we're translating down to 3 units, which I know that equals 2, and I'm going to substitute our values in. So I know it's negative 2 times by, and I'm substituting x minus 2 into my original equation. That's root x minus 2 minus 3. Or in other words, negative 2 root x minus 2 minus 3. You'll note that we did the dilation first, which ended up not affecting our translation. Yeah, because if I messed the step up and I did this, and don't write this down, and I did this, right, that would affect our vertical translation as well. Okay. Would you like me to do one more example of this style, or would you like me to move on? It's a vivid response. Wow, guys, calm down, calm down. I'll do one more question, and then we'll move on to the next section. A reflection in the x-axis, so we're still doing the same y equals root x. Reflection in the x-axis, so that becomes f of x, translating towards negative f of x. Not translating, sorry, reflecting. Right? And that goes into, and let's see, it says translation of 2 units to the right, 3 units down. Now you note it goes reflection, translation, and then tells us dilation. It's telling us the specific order, we follow it. But the DRT is something we follow if we've been told a certain, no, sorry, if we're trying to identify the certain steps. Okay, but in this case, we're told a specific order of reflection, then translation, then followed by dilation. We follow their order. In which case that becomes negative f of x, and it says 2 units to the right, so again it's minus 2, and then of course 3 units down, minus 3, which then maps to, I'm going to do it down here, then maps to, because it says a dilation of factor 2 from the x-axis, so again still from the x-axis, it's a y, along the y-axis dilation, so that becomes 2 times, but you notice it says then followed by dilation, that's last, so I'm going to multiply everything we had before by that 2. Substituting our values in gives us negative 2 root x minus 2 minus 6. I've skipped a couple of steps there, but I'm sure if you work it through, it'll be fine. I'm actually going to do the coordinate mapping one for this question as well, because I think it's an interesting approach. Again, either or works. So of course we start with x comma y, mapping towards, now it's a reflection in the x-axis, so that becomes x comma negative y, because we're reflecting all our y values opposite. So don't think about the letters, unless you want to memorize. I know some of you guys like memorizing formulas, that's fine. But think about how it affects our graph. Now that maps towards x plus 2, negative y, minus 3. Oops, minus 3. And then we apply dilation, and that becomes bracket x plus 2, comma, sorry, 2 times negative y minus 3. Note that the dilation comes last, so we multiply everything in the y ordinate. Or in other words, that becomes x plus 2, comma, negative 2y minus 6. Now identify that x dash equals to x plus 2. This is from last lesson. I identify that that is my transformation. And this is why the coordinate mapping becomes a little bit easier, makes more sense. In the previous lesson, it's more so just to teach you the instructions, but now that we know how to apply those instructions, makes this a little bit easier. I'm going to rearrange that, of course, to get x equals to x dash minus 2. Here, same thing, I'm going to do the same thing to the y ordinate. I know that y dash equals to what I got, which is negative 2y minus 6, which rearranges to y equals to, I'm going to write this a bit higher, here we go, which rearranges to y equals to y dash plus 6 over negative 2. I'll zoom in a bit. Apologies for the lack of space. And then, all we do is substitute our values in. We could get y dash plus 6 over 2, because I'm substituting my y with y dash, our transformation, which equals to root x dash minus 2. This is really hard to read up the back. That's all right. Okay. And I'll trust you to be able to rearrange everything. You transpose it, bless you, and you get y dash equals to negative 2. I'm going to write it down below. Bless you again. Y dash equals to negative 2 root x dash minus 2 minus 6, which gives us the same answer. When it gets more complicated, sometimes coordinate mapping seems a bit easier. You're welcome to do that. We're going to jump to question 5. If you'd like to complete questions C and D in your own time, you're welcome to do so. We're going to jump to question 5. Now we're focusing on the image of the graph under transformations. Again, it's specifically under a following sequence of transformations. In this case, we're reflecting the x-axis, dilating factor of 3 from the x-axis, and then translating 2 units to the right and 1 up. So again, we tackle it step by step. A reflection in the x-axis. Now, does that only affect the line? Essentially, yeah. Does it affect our asymptote? If I reflect the whole graph in the x-axis, am I reflecting horizontally or vertically? Vertically. which means my asymptote also needs to be flipped as well, doesn't it? So I'm going to end up getting an asymptote here. I'm going to use a red dot for this one. Then I just do the same thing. I draw a C, just opposite. That's the first one. I'm going to switch color for the second one. It says a dilation of factor 3 from the x-axis. So if it's from the x-axis, is that vertically or horizontally? Vertical, thank you very much. So we're dilating, so that becomes 3 here. So before it was -1. We've moved from 1 to -1. Now it's down to -3. And we're going to try our best, or I'm going to try my best, to draw this without making it look awful. There we go. That's the purple one. Finally, it says a translation of 2 units to the right and 1 unit up. Yes, it looks very messy, I do apologize. But we're going to move 2 units to the right, 1 unit up. What I'm going to do is what I call anchor points. I find anchor points, I'm just going to shift them, right? So the origin goes from the 0, 0, 2 units right, 1 unit up. I'm going to say it's about there. Same thing with that other x-intercept. I'm going to say 2 units right, 1 unit up. It's about there. That one should be a bit lower, apologies. There we go. And I'm going to say the turning point should be about here. Oh, let's move it across a bit, sorry. Let's say about there. It's all approximate. There's no specific values anyway, so we're fine. Okay, now with that, does our asymptote change?
Yes.
Why?
Because you're moving the graph.
Good, we're moving the whole graph up, which means you have to move the asymptote up as well. So I'm going to do another dotted line between here. Yes, it gets very messy. And then I'm just going to essentially connect the dots. It'll look something like that. Very messy, but the idea is that you know how to apply those transformations. Any questions? Okay, I'd like to jump onto one last type of transformation question. The one we're focusing on is determining transformations from an equation. So beforehand, I give you an equation, I say apply these transformations, then you give me the equation, the new equation or the new graph, right? In this case, I'm going to give you 2 equations and you tell me the transformations in order, okay? Do note, in advance, there are multiple answers that are applicable, especially with the whole in the x-axis or along the blah, blah, blah. There are multiple answers, so don't just assume that you're wrong if you have something that's slightly different, okay? Double check your responses in the calculator. Again, DRT applies here, but I also want you to write this section down here. Image, and I'll explain what it means in a second. X/y, transformations, x-y'. If you are looking for the image, you've been told to find the image, which is the new equation, you solve or rearrange for x, or you rearrange for y. If you're looking for the transformations, you rearrange for x-y'. Okay? So we've been doing x, y before, we do x-y' now. That's essentially what that paragraph says. So let's try by finding a sequence of transformations which takes the graph of y equals x squared to the graph of y equals to 2 bracket x minus 2 squared plus 3. So first thing I'm going to do, I'm going to rearrange this equation so it looks more like the y equals x squared. In my y equals x squared, there is no constant on the right-hand side, right? I want x to be very clear what x is being replaced with. So I'm just going to subtract both sides by 3 and divide both sides by 2, and I'll show you why. So y minus 3 over 2 equals to x minus 2 squared. Is it very obvious now that x is being replaced with x minus 2? It's very obvious. I want to rearrange the equation so that it's in the form that's provided. Now, I'm going to write y equals to y dash minus 3 over 2. Note that the dash comes into the transformed equation. This rearranges to y dash equals to 2y plus 3. I'm going to assume that we're okay with transposing. I do the same thing with x. We get x equals to x dash minus 2, which again transposes into x dash equals to x plus 2. Now we're going to apply our coordinate mapping. So we start off with x, comma y. We map to, now remember, it's dilations, reflections, translations. In this case, I'm looking at this one right here. That's the only dilation we have, isn't it? So I'm going to write that first. I'm going to write x, comma, to y. And then reflections. Do we have any reflections to worry about? Not really. So then we focus on our translations. So that becomes x plus 2, 2y plus 3. Now, in future, you don't need to write out each step. However, for me, it makes the most sense because we're going to write these steps out. I'm going to type it out because I'm lazy, but you will have to write these out in similar wording. Okay? So, 1, it's a dilation of a factor 2 from the x-axis. You may write along the y-axis, that's fine, you don't have to write both. 2, it says, here we go, we translate, now it doesn't matter which one you do, x or y first, because it's in the same category anyway. So we say translate 2 units in the positive direction of the x-axis and 3 units in the positive direction of the y-axis. Now, do note, normally for x values, we are compensating. In this case, it's a coordinate mapping. We're literally saying that we plus 2 to x. It's not saying a function. So we just read it as plus 2, move 2 to the right. Any questions about that? Okay. That's the last style. However, there is an alternate version of that I just want to get in through. I do apologize. I know it's a very long video. I'll try my best to keep it short. Okay? You guys can watch it on 2 times speed anyway. So, here is the last one. I'll flick back so you can read it later on. This is the last style. In this case, the only difference is that we're going from the more complex equation into the simpler one. It's the exact same process, except we have to make sure that we identify that. So, I'm going to very quickly write this down. We know that we start off, and again, we rearrange. So that becomes y minus 6 over 3, which equals to 1 over x minus 1 squared. Again, you'll note now 1 over x minus 1 squared is a lot simpler to identify than 3 over x minus 1 squared plus 6. I know that y dash, because in this case, I do need to specify this, the equation that we're transforming into, or the image, is the basic y equals to 1 over x squared. So now, it becomes, I'm going to write it over here actually, y minus 6 over 3 equals to y dash. You can transpose that to 1 over 3 y minus 2. Not transpose, sorry, simplify, that's fine. Same thing. I could probably replace that with an equals actually. There we go. X dash equals to x minus 1. Simple, no need to rearrange that. And then we do the same thing we did before. We start off with x comma y, which maps towards, now our dilation is what we address first. That's the 1/3, so it maps towards x comma 1/3 y, which maps towards, now we apply our reflections. There are no reflections. Great, move on to our translations. That's our x minus 1 comma 1/3 y minus 2. You'll note, bless you, you'll note that I separated out, instead of writing y over minus 6 over 3, that can get confusing, it can get very messy. So I've just separated out to get 1/3 times y, and then I've got a translation on the side. And then, and I'm not going to write this in proper mathematical notation, because again, I'm lazy. So we're going to write 1/3 dilates this way, which is vertically, and then 2, we're going to move left 1 and move 2 down. But you know how to write that in proper format, proper notation.